In question number 6, we're being asked to solve for the sine ratios, solve for the angle. So if I'm solving, I'm going to use arctan to solve. So to set this up, angle theta equals negative 0.291. So this looks like this when I set it up with arctan. So arcsine. Arcsine of the ratio 0.291 is going to be equal to theta, and my calculator will give me theta 1, and I have to work out the other angle. So drawing a picture of this then, just going to draw a picture here. I have negative 0.291 is going to be somewhere around here in quadrant 3 and quadrant 4. So that height here, that distance, the y coordinate is going to be 0.291 in the unit circle. So then using my calculator, I'm going to undo that sign to get the angle, and I get one angle is going to be negative negative 0.295. So I'm going to round that to negative 0.30 radians. So this angle in here, I'm just going to circle this angle in here is going to be my theta 1. It's going to give me this position here. So that's one angle. There is another angle that I have to solve for over here. And I can measure it. I'm going to measure it in this direction. And to find the theta 2, so I'll write this as theta 2, it's going to be found using pi minus theta 1. In this case, it's going to be plus minus negative 0.30. Let me just move that over so you can see it a little bit better. Okay, so pi minus negative 0.30 is same as pi plus 0.3. So we can see that we're going to add that little bit of angle that we went backwards with. So pi plus 0.3 is going to give us, let's see here, it looks like it's going to be 3.44 radians. So that's going to be about 3.44 radians. And so that'll be that position in quadrant 3. So our two solutions then are going to be negative 0.30 and positive 3.44 radians. And again, when we solve for angles from a ratio, we need to consider theta 1 and theta 2. Now, the other thing we need to consider is this is for all real numbers. So these are just theta 1 and theta 2 represent one solution, solutions in one period of our sine function. But the sine function repeats itself, and it repeats itself every 2 pi. So to get the repetitions, we do this. We do plus n2 pi, where n is an integer. Okay, if n is an integer, then as we change n by increments of 2 pi, we're going to go around the circle and just keep hitting that same red position every 2 pi. And then we do the same with the other angle. We need to do plus 3.44 plus n2 pi, and again, n is an integer. So what ends up happening is we can get back to that same position every 2 pi. So we start at 3.44, we go backwards or forwards 2 pi, and we get all the repetitions. And the repetitions is what we need. So this part here, and this part here is due to the fact that we need all the repetitions or all real numbers.